It's so annoying, those network issues. I have to find a better solution. Hope I'm connected now. All right. Let me just quickly check my YouTube if it actually works. Yeah. All right. Oh, that's annoying. That's so annoying. Now I lost you, chat. All right. I think I'm just going to... I don't even know where the connection lost. I kept talking and talking and talking and explaining you guys what I did, and I think maybe I lost all of that. And which chat session am I connected to here? No, that is the wrong one. Yeah, all right. Oh, that's so annoying. So I don't even know what to do now, because I don't even remember. I don't know when the stream stopped. Should I start all over again? Hey guys, are you back? I think someone's back. Can you hear me? I should use the cable again. I have a new Wi-Fi router, and it works really well, except for my old laptop that I use as a streaming laptop. And for some reason, it does not connect well. And I think that was the reason why I just lost the connection. Pies, you're back. Hey, I'm so sorry. For some reason, the connection got lost, and I didn't. And I just kept talking and talking. And I kept on showing you what I did, and I think you saw nothing of that. Am I right? Did you? And I said I thought it was me. Yeah, no, I was just like explaining all of the things that I did last week. Did you? How far did you get? Like, or when did the stream stop? Should I just start all over again? And I even did a giveaway. Wenderson won a Nano, and then I noticed, because no one wrote congratulations, and I thought that's weird. Oh man, still having frame drops. All right. So where Andefnal or Pies, when did the stream stop? What was the last thing you heard? Yeah, I have to work on my setup. That's just too error prone. What was the last thing you saw on stream? I don't remember. I was panicking. Oh man, all right. Quickly recap everything that I just said. So back to the diagram. So I explained that in the last stream I'm getting huge frame drops. It's so annoying. What should I do? Hello again. Hello, Sergio. Evie Bob, hey, you're also here too. Let me put you on the wheel. All right. Anderson says it lags from time to time. I'm scared as fuck. Yeah, it's me. It's not you. You know, guys, this is so annoying because do you see that glass door? And my Wi-Fi router is directly behind that glass door. So how can this connection be bad? It's directly behind the glass door and it does not work on this laptop. And I used a cable in the past streams and then I got a new router. And I thought with the new router, I don't need a cable. But the problem seems to be my laptop, or the streaming laptop. I'm using two now, one for streaming and one for coding. Yeah, all right, so... yeah, so I was talking about... Oh, and I have to restart the timer. All right, timer restarting. So, yeah, okay. I refactored the message. So, Anderson says, as far as I know, is the recommended setup. Yeah, but with the Wi-Fi thing is the problem. And my streaming laptop is a bit old, but it has enough CPU power for streaming. But for some reason, the Wi-Fi chip or whatever is just really bad. Yeah, I learned my lesson, chat. Won't do it again, I promise. Next time I'm using a cable again, okay? 6% frame drop. All right. Yeah, so I was unhappy with this design. Then in the last stream, I said I wanted to refactor it to look like that, so that we have a message struct that has a payload enum and a message header. And then I thought, no, we don't even need a message header because we only need the header when we send bytes to the network, because the receiver has to get some information first about the size of the net message and the type of the message. So that's why was when I realized that we don't really need the header at all places. We only need the header when we send the bytes to the network. And then to look like this here. So what we have now is we have enum message with all the different message types, and those are just I'm losing connection again. This is so annoying. I'm panicking now. Yeah. I'm panicking now that I'm afraid I will lose the stream again. Yeah, so... Oh, and as LF says, maybe get a USB Wi-Fi dongle if you want to keep using Wi-Fi. I think I still have one, now that you say that. I think I have a USB Wi-Fi dongle lying around somewhere. That's a good idea. I could try that. Yeah, so I said, yeah, we don't even need the message header. We just need a message enum with the data. And then when we send the bytes to the network, only then we have to create a message header. And all the other places in the RS Nano code, they don't have to know about message headers. And that would simplify the code a little bit. And that's what I did last week. So I created the message enum. It just holds plain old data structures, nothing fancy there. And then when we send the message over the network, then there comes in this new struct that I created. It's called message serializer, and it takes the message, then it creates the message header on the fly, and then it serializes all of that. In buffer is only allocated once when we open the connection, and then we reuse the same buffer for every message. And that's also new. That wasn't in the code in the past, and that also reduces allocations. And yeah, so now we have stack allocated messages, and we have a send buffer that is reused, So that also reduces allocations, and that should speed all of the network stuff up. So yeah, and that took actually a lot of time, that refactor. So that refactoring. LF says, how does message deserialization work now? Do you still have to parse the header beforehand? Yes, and that cannot change. That is the Nano protocol. Let me show the code. Let me show you the code. So we are in the folder messages here in Rust node messages. And there's this new file message rs, and here you can see the message enum that I talked about. And as you can see, it is really, really simple. These are all the messages the node can send and receive. And most of those messages have some extra data with them, and that extra data is in those payload structs. Ask pull uck, for example, has an ID and a pull type, and the pull type has more data in it. What do we have? Bulk pull. Bulk pull has start, end, count, ascending. And this is a good example because the count and the ascending flag, they actually are in the header, in the message header. So when we send this message over the network, the count and the ascending flag are part of the message header. But I made it, I refactored it into this style where it is just a simple data structure, and we do not need to know that, because that is, again, an implementation detail of how messages are sent. And let me show you the new message does all of that. This is it. Really, really simple. As you can see, it allocates, so it has a buffer. 1000. Das ist hier schon los. Reconnection successful. Oh, man. Are you guys still there? Hello? Are you guys still there? I just lost connection again. We're back? Yeah, I was just got completely disconnected. Oh man, this is so annoying. Let me just check one thing. I want to put the router in a different position. I'll be right back. All right. How does it look? Let's see. Maybe this helped. I put it on a on a chair. Yeah, I think this looks better. So LFL says, we see you, that's good. LFL says, you were just lagging hard and the resolution is bad. At least because is wearing pants. Oh yeah. I'm not always, yeah. Oh man. Is it better now? Let's see. Let's see. I think it's better now. So where was I? Yeah, so it's the message serializer. It uses this buffer, it reuses this buffer, and it has the serialize function, and the serialize function returns a byte slice. And that serialize, so this reuses the internal buffer, so it does not allocate. And it first serializes the payload, and it has to serialize the payload first because the message header sometimes contains information about the payload length. And that's why we serialize the payload first. And in the second step, we create the message header on the fly here. We set the extension bytes here. And then we serialize the header, and then we return the whole buffer. Oh, okay. Bitcoin block time. LFLF says, you came back interfering the stream stop for me. But now it's better, I think. Okay, I'm not getting so many warnings anymore. Let's see. Okay, let's see. Do I have all of you on the wheel? I hope so. 1 Nano 4. Oh, it's looking good for you, Eli Bob. It's looking good. Yes, it's you. There you go, 1 Nano. Start, restart. Maybe I found another issue. There was a stream preview in the background. Maybe that took... Yeah. Do you still have lags and bad resolution? I think it's good now. Congrats, Eli, yeah. So, timer running, alright. Yeah. By the way, the stream looks definitely better now, says Underfnal. Yeah, I think we can live with that now. Oh, that's so stressing. So I promise I won't. I will find a better solution for the next stream. Underfnal says looks fine. Okie dokie. So that is the way. That was. I worked on that, and then I found all of the places in the code that created and received messages, and I made all of those places use stack allocation instead of heap allocation, and to use the new message enums. And that was a lot of work, but I'm done, and it works, and I'm super happy with this. And now I still have to get rid of all of the old glue layer code that is still there that I introduced for the boost async runtime, and that code. So I mean this callback style async stuff that we worked on past streams, because that callback style async stuff is still copying data and heap allocating, and even using mutexes, and I have to delete all of that stuff. And then the network code should be really, really fast. And also, I would like to extract this message code into a Rust crate, and also the channel code into a Rust crate, so that you guys could just interface with a Nano node. And write your own tools. So for example, I don't know if Bob wants to do this, so Gravity, maybe he wants to publish his blocks, his test cases in Rust, and then he could just use that. So that's also on my list, so to create a reusable library for all the messages and the channels. So yeah, so that's it. So finally, after all of those interruptions with connection losses, that was all of the code that I worked on last week. Yeah, and maybe I showed you. Did I show you? Yeah, I showed you the messages. So they are just simple structs, and yeah, and this deserialization. So that, who asked that? Underfnal LF? I don't remember. So this still, let me just open up where is it called? The message RS. So message has a deserialize function, and it takes the stream, and it takes the already deserialized header, because yeah, we have to deserialize the header first. And then it just delegates to the detail structs, and they just take the extensions. So these are 2 bytes in the message header where arbitrary data can be stored, and the stream. So this is how it works now. What do you guys think of this new way the messages work? Any feedback on this? So you can have a look at all of that. Maybe let me just post the link to this code in chat. GitHub. And Fla says, oh, I love the match operator in Rust. I do too. I really fell in love with the match operator. LFF says, I like it. Thanks for the explanation. And Anna says, I mean, in PHP, it's great too. Oh, I don't know PHP, so can't comment on that. Does it have the same thing? So let me just send you the link in chat for the code that we just looked at. So, oh no, it's not in Nano, it's in the folder Rust. And they're in node source messages. So this here. So copy. So I hope this goes out to Twitch and to YouTube. I think it does. Yeah, so this is where all the message code lies. And also the message header struct and everything. So yeah, I have even refactored a lot more and I forgot all of that. But yeah, did many things here. Many refactorings. Andefnal says, yes, after years of painful switches, it found its way to PHP too. Yeah, PHP changed a lot. It's not the same anymore. So I worked with PHP many years ago and then I never went back, but I think it's a completely new language now. So let's see. So now to the next part, and the next part is to work on something. And I'm not sure what we will do today. So we could, let me just open up. I have this to do. I have this to-do list still. Where is it? To-do stream. Here it is. I open it up here. Move it here. Oh, I have it open already. Here it is. Stream to-dos. And I think we can just remove all of the things that are done already. So return error code in message deserializer. So correct error code I have fixed that. A-frame architecture for message deserializer. Yeah, that is done. Use new async message deserializer and delete old. That is done. Convert message to enum. That is done. Convert message header to header payload. So I made a different solution that I just showed you. So, but that is done. Remove parse status field from async message deserializer. That is done. Okay, we don't have much left. Buffer reader should take byte slices instead of arg mutex vacuate. Yeah, so that is something tricky, but we have to do that. And integrate message deserializer impl into, yeah, okay, so that, yeah, I didn't tell you about this. This is also an idea that I got while I worked on the message code. And that is, in the last, was that the last stream or the stream before, when we split the message deserializer into two parts? The one part with the logic, and one part that did the async stuff. I think I still have the sketch. Yeah. So that is this here. So we split the message deserializer into the part with the logic in it. And then we have on the application level the async message deserializer that orchestrated the async calls And then it would just pass byte buffers to the logic part, so that the logic part was completely free of async code. Remember when I had a tough time finding a name for a message deserializer, and then we just settled for message deserializer impl, and I said, yeah, it's as long as we can rename it later. So I thought this deserialize code should go into our message enum, and then we don't have this stupid impl name, and the code would be inside the message struct. And that would just fix this horrible name here, and it would move our code to the message struct, which is the logic part anyway. So it would be in the right place, if you ask me. But, oh, well, if we wait time, where is the wheel? And what is the, oh, okay, 2% drop frames. That's better now. That's definitely better now. And end of now, you get 1 nano. One nano for you. Yeah. Successfully sent, and let's restart. Underflow says rigged again. Cool, thanks. Yeah, I have a new wheel. Did you see that? Underflow. It's a new wheel. It can't be rigged. It's completely new. An unrigged wheel. Yeah, running again the counter. So Sergio says congrats. Yep. So what to do now? What to do now? Yeah, so some the message deserializer. So I thought about moving. We could work on that. So I thought about moving the all of that stuff here into the message enum. But it does too many things for my liking. So it does, for example, it doesn't just deserialize the messages. It also validates the proof of work part. And it also does, what else does it do? So yeah, so it validates the proof of work. It does the duplication filtering, so to deduplicate messages, and it does deduplicate blocks, and it does deduplicate votes. And I think this should be in a later stage, really. I think we should first deserialize the messages, and then later, in a second step, we should do these things. And then we could move these things to that higher layer. So that's just how I think about it. I think deserialization should just take the data, the raw bytes, and it should just convert them into something we can work with in a first step. And then in a second step, I want to do these higher level checks here. Same for the network ID. So every message has a network ID with it, and that can be beta network, live network, test network, or maybe even other networks. So also I want to just deserialize the message first into data we can work with, and then I want to do these checks. So one thing we could do today is, yeah, move these checks to one level higher, and then move the deserialize function into the message enum. Yeah, what is this? Filter duplicate, validate work, and validate header. So yeah, see even this one, validate header. Who calls validate header? Also the impl? Oh no, this is okay. So this is not called. This is called from the higher level. So this one, so we could work on this, or we could work on something completely different, and that is the TCP channel. And that is some horrible piece of code, and it's my goal to make this one clean and nice. But right now it is not clean at all. It is just a huge mess. Because it just grew with all of those refactorings and the switch of boost async runtime to Tokyo. So this just got really messy. And what I want to do here is I want to finally get rid of no, not socket. Channel TCP. I'm talking about the socket struct. Socket struct. I want to get rid of where is it? This thing here, the Tokyo socket facade. This is just a wrapper struct that I used in the past when we had the boost async runtime, but we don't have that anymore. So I want to remove this one, and then we can slowly simplify the socket class and make it async. And then we can hopefully delete all of those mutexes and all of that unnecessary copying of data. For example, so with unnecessary, I mean, for example, the write function. The async write function, it takes an argvec-u8. So that means whenever we send data, we have to use a vec, which means we have to heap allocate for every send. And I just want to pass a byte slice there so that we don't have to heap allocate for every message we send. And same for the read. Here we have the read part. The read part uses an arg mutex vec-u8. So this is even worse. We not only have to heap allocate, we also have a mutex in there that we have to lock. And so that has to go away too. And yeah, so in order to do that, we have to start at the bottom. And the bottom is we have to get rid of this here. We have to get rid of the TCP socket facade. So maybe, what do you guys, do you have a preference, chat? Should we work on something completely different? Let me know. So if you are undecided, then I'm going to work on yeah, I'm not sure. I think I'm going to work on this socket stuff, and this would be just really messy and maybe fun for you because you would see me work with all of that horrible code, but and if no preference, you're the one doing the work. So yeah, but all of the work has to be done, so it doesn't really matter. So one thing is easy, so the message serializer stuff is easy, but I think you haven't seen me get into trouble for a bit again, so maybe I just start something that is complicated and then I mess it up and then I end the stream frustrated. So that is the plan for today. LF says messy refactoring sounds like a plan. Yeah, I'm going to do it. I'm going to work on this. I'm going to make this mess even messier. So that is the first step. Make the mess even messier, with the hope that we can clean it up then. So let's see who uses this socket, TCP socket. Oh, so many usages. Oh, that surprises me. That's a lot of usages. Okay. That's great plan for Tuesday night. Yeah. So, yeah. My plan is to fuck it all up and then to end the stream. And then on the next Tuesday, I think I can present you with a better solution. Okay, so we have many usages of that. And it uses the state. TCP socket state. I remember. So the state was guys, you're going to laugh about this because okay, today you will see a lot of really bad code. You will see a lot of really bad code today, and our task is to clean this up. So I remember introducing the state for reasons. So I could tell you the reasons, but they don't even matter, really. So I had to do it like that because the code was like that. But now it's not like that anymore, and we don't have to do it like that anymore. So that is the short explanation. It has this state, and the state is it represents our socket state basically, and it can be closed or connecting, or it can be client or server. Oh. Giveaway time. Wenderson. Nano is the light, Wenderson. Wenderson. There you go. Oh, I have to click send. All right. Yeah. So we should get rid of this state, because basically what we use in our socket is only this one, only a TCP stream. And with this closed and connecting, I don't know, maybe we find a better solution. So what other usages do we have? We have the current action. We have the local endpoint. What does that return? Okay. Oh, so many usages. I'm already regretting my decision to work on this code on stream. Is alive goes to is open. What is open? Oh, it just checks that it isn't closed. All right. What else does it do? So I'm just trying to get a feel for all of the places that we have to adjust. So my first idea is to move the state field out of the TCP socket and into our socket struct. Not sure if this would cause huge conflicts. What about, it uses the runtime, that's okay, runtime. Oh, I think I have even better key bindings here for navigation. So state, socket post, that goes into the runtime, post. Okay, let's go through this one by one. Let's start with the simplest thing that comes to my mind. And the simplest thing is this post. This post call, because this post, I think it is just delegating it to the Tokyo runtime. So let's start here. So it has a weak pointer to our runtime. So maybe a first step is to copy that weak pointer to the runtime into our socket struct. Where's the socket struct? I should split this file. It's too big. I have trouble navigating here. So here's the socket struct. Yeah, so let's put the runtime into our socket. And where do we create the socket? I think there's a builder pattern. somewhere in this file. Oh, this file is way too big. Way too big. Oh my god. Here it is. So async runtime. Why doesn't it? Oh, huh? Async runtime is. So where do we get the async runtime from? Yeah, it is a required argument, so we can't skip it. So that's why I have to put it here into our endpoint type, which is basically the first. This is the first function of our builder that we have to call. So let's add our async runtime there. Arg. Async runtime. And then we can put it here in our builder. Arc async runtime. I'm wondering, why does it use a weak pointer to the async runtime? Was there a memory leak that required me to do that? Async runtime. Async runtime is missing, so async runtime. Let's add it here. And down there we also have to. Oh, but runtime weak async runtime. Does this have to be? No, it doesn't have to be pub. Why doesn't it suggest the? Why doesn't the code completion work here? So this is this arc downgrade self.async runtime? Maybe we can convert this into an arc instead of a week. I'm not sure. So there's a problem here. Expected arc reference found arc. Oh. Expected 4 arguments, found 3. So now I'm just fixing all of the errors we get. So that is here the create null. Oh, do we still use that create null function? Yeah, just one usage. So oh man, I don't wanna. Do I have to create an async runtime here? I think it even does here in this create null. Oh yeah, it does. Oh, I'm just using the TCP facade one. Oh, but this is a weak pointer. This is a weak pointer, so I can't. Why doesn't it show me this as an error? I can't pass a weak pointer as an arc. Can I? No, that's not possible. Should we convert this into a weak pointer? Doesn't make sense, because why should we create a socket if we don't have an async runtime? That just doesn't make sense. Oh, did I just call it runtime? Okay, so that made... Wenderson says, oh, did I not read this? I agree with you, Nano is the lights. And Wenderson, this is your saying now. I will always think of Wenderson when I hear Nano is the light. He says, you're doing a great job. Oh, thanks. Yeah, sometimes a bit chaotic, but usually it works out well. I know how to dig myself out of a hole again, so that's a good thing. So I don't have, I should have errors. Why don't I see any errors here? Let's just do a quick cargo check. And maybe I have to... Oh. What is that? Serialized save? Oh, I worked on this today, but... Oh, what is wrong here? Oh. Nothing? Changed? Minor simplification in socket? I think my caches are wrong. I think I have to... Yeah, like guys, let's just stop NeoVim and let's delete the build folder. Let's delete everything in here because there's something wrong with the caches, I think. And now let's run cmake. Oh, I don't have it in here. Oh, where's my cmake command that I always use? Just 1 second, guys, sorry. Just 1 second, guys. Where is my cmake command that I always use? Here it is. And then I'm just going to rebuild everything. Yeah, so let's do a make core test. Okay, that giveaway is just the right time now. Because now we can just let the compiler do its thing. And we spin the wheel. 1 nano. 4. It's rigged. How do you do this, Underfnull? How do you do this? Like, I switched to a new wheel and still you rigged it. How did you do it? Underfnull. 1 nano. Okay, building. Oh, restarting the timer. Okay. You said it's unriggable. Yeah, I thought it was unriggable. I underestimated your riggability. Error. There was an error here. Oh yeah, because that error is. Thanks, by the way, it says Underfnull. Yeah, you're welcome. So that error now, it must be in our socket struct where we worked on socket rs. There it is. And is there an error here? 1,000 lines of code. Maybe, yeah, why not? I could take some time and split this file up. Because what does it contain? It contains the socket facade stuff that I wanted to delete. It contains this socket facade factory that I want to delete. And then the socket observer, null observer, socket observer. And then the socket. Oh, we have time. We still have an hour. So, yeah. Why not? But first I have to fix this error here and then I can split the file. So line number 870. There's something wrong there. Oh, in TCP channels. 870. Okay, so this creates, this creates a socket and we have to give the socket the runtime. Not sure if we have one here. This is the struct TCP channels. Does TCP channels have the async runtime? Oh, it has way too many fields. That is too many fields. Yeah, it does. It does have the async time, but it's also a weak pointer. So let's keep it a weak pointer for now. We can change this later. We can change this later. So let's go to input type. Let's make this a weak pointer. And what is wrong there? Construct mismatch types. Yeah, so this also has to be a weak pointer. All right. Okay, let's wait for the next error. Okay, there we have it. The next error is socket rs line 1001. Socket rs 1001. Yeah, so we don't have to downgrade because it's a weak pointer already. And we can just move that async runtime into our socket. I'm going into the Rust folder and execute a cargo check because that is just faster than compiling. So input type, so yeah, server socket rs has a problem. Server socket rs has a problem. Oh, many problems. Okay, so we do have to give the async runtime here too. Oh, but we don't have it. We don't have it. Yeah, so that means we have to add it to the constructor. It has way too many. So how many arguments can a function have? And that is just way too many here. But I warned you, you're going to see some really bad code today. But don't worry. I'm going to clean it up. I'm going to clean it all up. So I won't leave it like that. I promise. Runtime. Okay, so here, can we pass? Give the... Wait a second. Which function is this here? On connection. So we have to say weak clone. What is this L? What is this? Server socket. It should have the runtime. Why doesn't it have a runtime? Server socket. I added a runtime, or didn't I? Oh, I didn't. Okay. Oh, that's why. Because I have to... First I have to pass the runtime into our socket builder. And later I still have to assign the runtime to our server socket. So let's cargo check. And errors here, everywhere. Errors everywhere. Socket rs. And where is the error? Borrow of moved value. Oh yeah, but I can just clone it here. that. And then I can just pass the runtime in the function here. Okay, cargo check again. Socket RS. Oh, this is a foreign function interface. Error here. Okay, so this is the C++ glue code. Even worse. And we need the runtime, and I think we can just clone it from... Ah, no, here it is. Here is the runtime. So we can say runtime is async rt dot 0, which is the actual async runtime. Dot the what is that? An arc. I say dot downgrade? No, what arc downgrade? Arc down. Oh, we have a Nano address in chat. Let's do it like that. Like that, yeah. And you are just in time. 1 minute left for the next big Bitcoin block. Craptor. Oh, I think you are in my address book already. Are you? Aren't you? Craptor, and is this the same address? It is the same address. So yeah, welcome to chat. Welcome to the stream. Lollipop and Craptor. 30 seconds, and then we give away 1 nano. Thank you. Yes, you're welcome. All right. No more errors here. Let's cargo check one more time. And what is wrong now? Oh, a syntax error. A syntax error. Yeah, let's do the giveaway first. Oh, Wenderson. Ah, Nifnal, you rigged it. You took it from Wenderson. All right, 10 minutes. Yeah, it's your lucky day, Nifnal. Master of the rigged wheels, yeah. Master wheel rigger, Nifnal. All right, so this one. Where's the syntax error? Unwrap, no, thread main parent caused by failed to run custom build command. So I think I just introduced some syntax error here. But where? Cropter says, I think Underfall is Gustav's alt account. Oh, there, you got me. Oh no. Just doing all of those giveaways to myself. Next time we will give away 1,000 nanos. And all go to Underfall. Every wheel favors those from Twitch. Yeah, that could be. Oh, well, so what's wrong here? What is wrong here? This function takes 12 arguments, but 11 arguments were supplied. 12 arguments, that's way too many. Server socket RS. A function should never take 12 arguments. That's just horrible. Today is a an anti-clean code show. So you can see all of those things that you should not do. Yeah, so this should take the async runtime. And we can clone it again from... Oh, we have it here. Yeah, so we can say let runtime is weak. No, is arg downgrade async runtime.0. Crypto says, reminds me of the... What is this Walton chain crypto that forgot to log out of their main account and posted this on Twitter from their own account? What? I don't know this story. Crafter says, oh my god, can't believe I won. Thank you, Walton team. Keep doing the great work. That's you guys, you bring me to new ideas. RS Nano, 1000 Nano giveaway. Thank you, Gustav. And then I send it to myself. That's just 200 IQ then. That's... Oh, no more errors. No more errors, so that's good. So we have the first step. And... So let's do the next thing. The next thing is to actually use this field. So we have introduced this field now in the socket struct. But we don't use it yet. But now we can. And we can use this new field. Or should we? Let's split this file first. Because I just can't handle a file that big. It just confuses me. Andefnal says, I'm actually on the same Wi-Fi. That's how I can rig it. Yeah, so Andefnal is me. So guys, there you have it. That's my alt account. Yeah, so I want to split this file. Yeah, let's just move the Tokyo socket facade into its own file. So let's create a mod, Tokyo socket facade. And let's create the file. Let's go there. And then we open the old socket here. And then we can just select all of those. Yeah, all of that. I want to move all of that into the new file. Oh. Like that. Move it all here. I left end of now. You are overloading it. Stop rigging and because the streams won't stop randomly anymore. Yeah, maybe it's the rigging that brings my network down. But now the network looks really good. And you know, guys, the only thing I changed is I put the Wi-Fi router on a chair. So that solves the issue. Send that arc, so I have to import that. Oh no, that was the wrong week. I have to use the week from sync. And the mutex. And the TCP stream factory. And the TCP stream. And I think this is my nullable TCP stream. And the TCP stream listener is Tokyo listener. Yeah. Socket address. IP address. And what's that? Our clone listener. Unexpected. Ah, what's wrong here? Up here, tries v6. Error code. More and more errors. Any. So let's just clean this one up here. This one and this one and this one. And back to here. So what is wrong there? Listener. What is listener? And if not says LF, you will get the next Nano, I promise. Hey, Amadeus, I'm here, gang. Hey, Amadeus, how are you? Let's put you on the wheel. So, yeah, 2 minutes left until the next Bitcoin block arrives, and then we give away one more Nano. How many Nanos do we have left? 4. Is that correct? Because I noticed sometimes the balance here is just slow. No, it's correct. Four Nanos left. Listener, what's wrong with the listener? Enum, what's wrong here? Enum, what does the error message say? I can't read it. It says exists but is still inaccessible. Oh, this is an accessibility issue. Enum Tokyo socket state exists but it is inaccessible. Who uses that? Do I have to make it public? Probably. Okay, so now we have that last error down here, which says expected arc unknown found arc TCP listener. Why does it say expected arc unknown? This is the TCP listener. Why does it say arc unknown should be? Is that the... Oh, let's just run cargo check. Okay, socket RS has errors, so let's fix those first. Oh, so many. So many. Okay, yeah, so we have to import this thing. Giveaway. So let's see if LF gets his... Oh, I would have laughed so hard. That was close. And if all your rigging didn't work well, Amadeus won. So where is it sent? That. All right. Amadeus, yeah, that's lucky. You join the chat and you win a Nano. That's cool. Do you guys know the story about those guys who cheated at the roulette table many years ago, very successfully, and they had a small computer, and whenever the ball, I think it was like this, whenever the ball crossed a certain spot, he would click something with his fingers, and the computer could then calculate where the ball was likely to land, and then he had some device in his foot, in his shoe, I think, that would give someone, no, it's some other, there was a clicker standing at the roulette wheel clicking, and then there was another guy sitting on the table, and he would receive vibration signals in his shoe, or in his or no or on his leg. He had some device somewhere on his leg or in his shoe. I don't remember. And then he would receive vibration signals, and he would know where he should bet. And they rigged the game there. So they won a lot of cash until they were found, until they were discovered. That's a really interesting story. LFLF says, that sounds so complicated. That must be what Andaf is doing here. And you know how they caught these guys? I think the device had the vibrating device, it has a malfunction, and then it was just, I don't know, getting really hot or completely vibrating, and the guy was just twitching or behaving very strangely, and then they had a look at him, and then they found this device. So yeah, let's fix all of the other errors here. There are no more errors in here. Oh, there are. But let's just focus on those errors first. Field runtime is private. Let's make it public. Consider importing. What is private? Current action. Yeah, I have to make all of those fields public because I want to inline them. I want to inline them anyway, so let's make all of them public. Tokyo socket state. Import that one. Oh, was that it? Target check. No, still something wrong in server socket RS. Unresolved imports. Okay, they are now in a different namespace. No, let's fix it properly, and let's go to the mod RS, and let's just say Tokyo socket facade. This will be deleted anyway. Oh. Tokyo socket facade. Oh, there's. Okay, there it is. So dref, we have to import dref. Ah, that was it. Okay, we're green again. Let's run the tests. Oh, why does that take so long? Running. What's going on? Not much. Okay, here we go. Tests are green. Okay, back to socket. Because how long? Okay, 300 lines of code less. Still huge. Maybe we can split more. The socket observer. Async buffer reader. So this should also not be in here. Oh, okay, no, this is in trait implementation. Yeah, so this should be here. Craptor says, nano pumping. Soon you must give away half a nano. Is it pumping? What's the current nano price? Is it? Let's have a look. Let's have a look at the current nano price. Oh, it is pumping. Hui. Ooh, guys, what's going on here? Maybe the dev meeting today was really impressive. Who knows? That's cool. What's the trading volume? So I'm only looking at Kraken because that's my exchange of well, how to say, that's the exchange that I use mostly. 4,000, yeah, but the volume is 10,000 nanos here. Yeah, interesting. Who was that? Someone of you guys? I'll keep it open. Let's keep it open and let's keep an eye on it. So, oh guys, I have to go to the toilet really quickly. I'm so sorry, I have to pee. I thought maybe I can hold it until the end of the stream, but I can't. I'll be right back. Again. Back again. So, did I? No, Bitcoin timer still running. Yeah. And price. Yeah, okay. It's not really pumping, like, these are just normal things, I think. Normal movements. Alright. Okay, so now finally can think more clearly now. Yeah, I could split it, but let's not split this now. So things are green, tests are green. So I added the async runtime. Raptor says the dev meeting today was pretty good. Nano seems to be getting closer to handling more traffic without CPS coming to a halt. Yeah, I haven't listened to the dev meeting and I couldn't join today, unfortunately. But I think I know what was said because I still read like the internal developer chat. And yeah, it's really exciting. And the work that Bob does, so Gravity, the work that he does is so important. It's hugely important for Nano. And yeah, I'm just really happy that Bob works so hard. And he really makes a difference. He really makes a difference with the testing. And that helps so much finding those performance issues. And then, of course, the others on the team are also like so quick in fixing those issues that Bob finds. So that's, yeah. Development has really changed in Nano, I think, for the better. Craptor, 1 Nano for you. So so today we're progressing very slowly, but that's okay, I think. It's late. So and I usually find it really difficult really to work on stream because it's so late. I have a whole workday after behind me. I find it really hard to focus. Where is the runtime? I added a runtime here, or didn't I? Oh, there at the end. Here it is. Here's the runtime, and now we can use that runtime instead of using our TCP socket facade. So let's search again for all the usages here. And Ricky, Crofter says, Ricky posted an image on Discord on beta testing channel. Last test he published 250,000 blocks at 2,200 blocks per second, and confirmations per second didn't go under 1,000. Wow. Oh, I think that is because of what Piotr did. Piotr, he found an issue with which caused our confirmation rate to go down in when the nodes were desyncing, and he fixed it. And that is a huge change that not from the code, but it has a huge impact. So what Piotr found there, that's a game changer. So I'm really excited about the next Nano version. There's going to be so many good things in there. Yeah, that was awesome work from Piotr. And that was hard to find, I think. I think he only found it because he spent a lot of time adding a very detailed tracing into the Nano code so that he could really see where time was spent and what happens to all of those messages and stuff like that. Block timer. Oh, yeah, Amadeus. Thank you. Where's the block timer? All right, so yeah, I just started it. Okay, yeah, so let's find usages of the post function, and then we just use our async runtime directly, and also dispatch. So dispatch is the same, I think. What does dispatch do? Spawn blocking, blah, blah, blah. So yes, I want to do that here. So just two usages in socket.rs. One is here in close, and one is here in set silent connection tolerance time. Yeah, let's inline that. Let's just copy that and let's inline it here. So we upgrade our async runtime, and then we say spawn blocking, and then we call this here close internal. And I'm wondering, why do we call close internal in a Tokyo thread? Do we have to do that? I don't think we have to. Close internal. It sets the close to true, clears the send queue. Set default timer. What is send queue, write queue? Is that thread safe? Yeah, it has a mutex. Yeah, I don't think we have to do this in a Tokyo thread. We can just call close internal directly. Why is this pub? Who calls close internal? Oh, a foreign function interface calls it. And who else? Server socket. Server socket does this too. Yeah, no, I don't think so. I don't think we need to do this. Let's not call it from Tokyo thread. Let's call it from the normal thread. Because then we can just say... Oh, then we can just simplify this to self.close internal. A lot simpler like that. But I'm not sure. Let's just run all the tests. So just to make sure, but I think this is safe. So let's build core test. And let's run all. Yeah, let's build core test. Let's run all core tests. And this can be done in the background, and we can focus on the next part. Next part would be so what's the next part? So let's again search for all usages of our Tokyo socket. No, how is the field called? Tokyo facade? Socket facade? Or Tokyo facade? Ah, how is the field called in our socket struct? TCP socket. All right. What are we doing here? Oh, look at that. Here we are cloning the runtime. So from the TCP socket, so here we can just say self.runtime, because now we have the runtime in self anyways. Okay, let's go on. What's here? State. We don't care about the state. Here we have a post. Building still. So here we have the post call. And all right, so I think we can just inline this too. Post does again the async runtime upgrade, and then it just calls spawn blocking. Yeah. Oh. Let's copy that. And let's see if we can inline this. Oh. So this would be the inline. Oh, this would be the inline code, and this would be the callback that we call here. And now look at that. This is, I don't know. I think this is even good, correct, how it should be, because async write. No, is async write executed in the Tokyo runtime or not? I don't think it is. So we can delete that, and this is the inline version. So what it does is, if self is closed, it upgrades our async runtime so that we have access to it, and then it calls spawn blocking and calls the callback. But this here assumes that we are not that we are in a Tokyo thread currently, and I don't think we are. So I don't think we actually have to spawn anything. I think we can just call the callback. Yeah, because this is still our old style that we want to refactor. So this is callback driven async. And here we can just assume that we are not in the async thread, in the Tokyo thread pool. Async, right? And I think don't we have the, this is the real async function, and here async write. Do we have that as a real async? No, not yet, but it will come. So still building. Okay, so yes, I think we don't call the runtime upgrade here, and we don't do a Tokyo spawn blocking. No, we just call the callback. We just call the callback and we return. Same down here. Same down here. So here, what do we do here? We queue the... Oh yeah, this thing, I want to refactor that. So currently the socket has a send queue, and the queue is a queue of messages, and I think 128 messages, or what is the max size that we use in the queue? Max queue, write lang, where does it come from? Where does this come from? Max queue size, here. Yeah, 128. So the socket has a message queue of 128 messages, and when this queue is full, messages get dropped. And I would like to refactor that, because it just brings a lot of problems, really, different types of problems. For example, with the dropping of the messages, I think a better solution would be for the bootstrap traffic to just sleep, and for the voting traffic it would be yeah, so we have to drop. That is true, but maybe we could drop earlier. So I think we should move the... I think we should move this flow control code higher up in our levels, so that it's not down there on the socket just randomly dropping stuff. I think it would be better if in a higher level we would have a fine-grained control of how much traffic to handle. Itty bop. 1 nano. There you go. But okay, so now I got totally lost in the code. I was working on removing the usages of our TCP facade. TCP socket, no, what? TCP socket, yeah. Still building, all right. Yeah, okay, of course, this build takes a lot of time because I deleted the whole build folder. I was just wondering why it takes so long. So it has to rebuild everything now. And yeah, let's restart. Oh, 10 minutes. So in 10 minutes, I'm ending the stream. And then I give away the last... Oh, I still have only 1 nano left. Yeah. 1 nano left. So the last giveaway. The last nano in 10 minutes. All right. TCP socket facade. Where is the runtime here? Yeah, so runtime, I have the runtime. The socket has the runtime itself, so we don't have to go through TCP socket, so we can change this usage. And here we have a post call. And where are we? Async write. So here we are back in async write. I think we can call the callback. directly. So this is when does this happen? If it is not queued, so if it can't be added to the send queue. Yeah, another thing that bothers me with the send queue is that we have to copy those buffers. So we have to have the buffers into as an arc vec u8, and that just means that we have to heap allocate all the buffers for all the messages, and I don't like that. And so I think it would be better if we would not have a queue in the socket at all, and we would just use byte slices, stack allocated byte slices, and yeah, and we have to move the flow control to a higher level and not into the socket. So what does this do? Not supported. So if it was not queued, we call a callback called not supported. And this, maybe we can just call the callback without switching to the blocking thread pool of Tokyo, because we still should not be in the Tokyo thread pool here. That's, but I want to, ooh, what is this? I want to run all those tests. Heap use after free. But I think this maybe has something to do with something what I worked on today, because I got this in the office a couple of hours ago. Probably not related to our changes. I don't know. Let's rerun those tests. But that is not a good sign here. Heap use after free, triggered by TCP channels. TCP channels. I worked on TCP channels today, so maybe I introduced a problem there. Read of size 8. Yeah, but I don't want to I don't want to search for memory issues on stream, because then you would fall asleep immediately, because that is the most boring thing to do. What is that? So okay, so here we have a post, and that calls the write queued messages, and I think this has to be a post, because otherwise it would be an infinitely recursive loop. So that actually has to use the post. So let's inline that. So F is this. We upgrade the runtime. And we call spawn blocking, and in spawn blocking we call write queued messages. Yep. Guys, I'm going to change that in the future. I don't want to have a write queue in there at all. Okay, what else? Down there, here we have, yeah, the runtime. We can go to our own version of the runtime. And here too. And here we have another dispatch. Set silent connection tolerance time. Why is this done in a dispatch? Why? Why is this done in a dispatch? This is, what is this? An atomic. This is an atomic. So this here is an atomic U64. I don't understand why this is being done in a dispatch call. Why isn't this done directly? I think we can do this directly. It's just updating a U64, atomic U64. So yeah, let's recompile and let's run the test one more time. I want to see if it still crashes. And this heap use after free, I'm going to investigate this off stream. And those memory bugs, they are so annoying to find. That can take up a long time to find stuff like that. Oh, see, now the build was faster. So build is already done. Let's just keep running those tests. And yeah, while those tests run, let's just have a look at the code again, and if we have maybe more places. So let's redo our search for the TCP socket field. Still a lot of usages, but not that many anymore. So this is all the usages we still have. We have a couple of places where we access the state field. And the current action. What is this? Is closed and is open. Current action again. State field again. State field again. Oh, what is that? This clones the TCP stream factory. Yeah, so that one we need too, I think. The TCP stream factory. And then it calls connect. Yeah, we definitely need the TCP stream factory. How much time do we have left? Oh, only 2 minutes. Okay, so that doesn't make sense to start that, does it? Okay, so this time we don't have the heap use after free issue here. And we have one failing test, but this optimistic scheduler test. So what I do right now, I run all of the tests at the same time with gtest parallel. And that causes some tests to fail sometimes because it just overloads the system and then it gets slow. And then those flaky tests that fail from time to time, then they fail a lot. So that is a known test that tends to fail when I run all the tests at the same time. Same for this peer container reach out. I have to investigate those. So those flaky tests, they are really, really bad. So tests should either pass or fail, and they should not be flaky and sometimes pass, sometimes fail, because then you can't rely on them anymore. I spent a lot of time improving the stability of the tests already, but there's still, like, here is a couple of outliers that sometimes fail. Yeah, I'm not starting any new refactoring. So we didn't do anything today, or much today, did we? Let's have a look at what we did today. Yeah, what is that? Oh yeah, we split the file. Yeah, that's... Okay, today was not very productive, chat. But maybe next week will be more productive. So I want to reformat the code. And yeah, let's give away the last Nano. But first let me commit. Let's add all of that. And then let's commit that and say... LFLFs, you made some progress improving your internet connection. Well, but that was a dirty hack, like putting my Wi-Fi router on a chair. I don't think this is considered as good practice for a good internet connection. Oh, let's call this commit stream number 20. Refactor socket. And let's push that. Underfloor says, we had fun, don't we? Well, I had. I hope you too. Wenderson says, very productive. I agree. No, it was not productive, not at all. Wenderson says, thank you for your dedication. Oh, thank you. Thank you for joining every week. And Underfloor says, so let's rig it one more time. Okay, Underfloor. Underfloor, have you rigged it or haven't you? Let's see. The last Nano. Let's do the last spin for today. Are you ready, guys? Let's go. And the last Nano is for... oh, is it? It is LF. It is LF. Oh, that was close, Underfloor. That was really close. And the last one is out. Okay, guys. Thanks for watching. Thanks for turning up here every week and supporting me in this journey. And it was fun, as always. And LF says you kept your promise, Underf. Yeah. Oh, you mean it was rigged for you then? Yeah. Okay, guys. So have a good night. And I don't know what we are going to work on next week. Maybe something more interesting. I don't know. Or if you have ideas, write me in Discord. So if there are any new viewers, I don't think so. I don't think there are. But if there are any new viewers, go to rsnano.com and join our Discord server. And you can find the link on rsnano.com. Like and subscribe this channel. And see you next week. Bye, guys.